We have left off in the topic of move semantics. I will start the Rustlings command, Rustlings watch. And as you can see, move semantics 1. This is it. So we don't have an assessment, so we will start right now. We start in the main function, and over here you can see we have vec0, which will be an empty vector. So as you can remember, we have created a vector like this in the last exercise, I guess, or before 2 exercises anyway. This is a macro and this is an vec object. So if you put the vec type and call it new, then this will be an empty vector which has been created, and it's assigned to vec0. So here we have a type of vec. Now, then we create another variable, vec1, and we pass vec0 here to this function. So we go over here, and as you can see, this is the argument we have passed, vector of integer types, and here we make this vector mutable. So we have passed this vector over to here, and here we assign it to a mutable variable. Then what we do is we mutate the vector or modify it, and we do that by pushing integers into this vector. So these integers will be passed to this vector, and then this vector will be returned. As you can see, the return type of this function is vector of integer values. So we go back here, and now our vector should look like that: 22, 44, 66. This is how our vector should look like inside here. And then this print line will actually print the name, which is vec1, and it will print the length of the vector and the content of this vector. Then again we will push an integer to this vector and print the same thing as we did above. So when we see the error message, cannot borrow vec1 as mutable, as it is not declared as mutable. So the problem in here is on line 13, and it says here cannot borrow as mutable. So it's got this error here, and that would be line 13. Now if we commented out this line, as you can see, it is compiling and it prints 2 times the same thing. So as you can see, we have modified the vector over here. That thing was actually working. but over here we have a problem. And that's actually just because on this line, line 9, we forgot to make this variable mutable. So vec1 should be mutable in this scope too, because here we are modifying vec1. Here it was possible because we have made it mutable, but this was only applying to this scope here inside function fill vec. Over here it was still considered not mutable. So if we compile it, and as you can see, we now have these two print lines because 88 has been added. So after this line we will have 22, 44, 66 and 88, which is the case here. So we are done. Now the second one, make me compile without changing line 13 or moving line 10. Again, we start in the main function, we create an empty vector, and now over here again the same thing. Actually you can see this variable here, vec1, is mutable, and then we pass vec0 to this function, and this function will actually push these values and will return the vector. So after returning this vector, again we will have a vector of these values. And after pushing this, we should have again the same thing like that. Now let's see what's the problem of semantics 1. So I forgot to actually delete this line over here. So I will open the second one. And we will see what's the problem. So the problem over here is actually that this value has been moved. As you can see, this is an empty vector, and because we pass it by ownership, so this value actually will be moved. And that's happening because, of course, move occurs because vec0 has type vec integer 32, which does not implement the copy trait. So anything that is actually stored in heap memory won't get copied by default. So this actually passed the ownership. And so we cannot use that after the ownership has been passed, which is the case over here. We use it again in line 13 and right here and here too. So what we actually can do is that's the simple method, we just clone this and it should work. Alright, and this works because we have actually cloned this. We've copied it manually, so this is now actually a copy of this. So this still exists, we can access it, but this is a copy. And we pass a copy over here and then modify this vector, return it, and this vec1 will hold a copy and not the original vector. So that's also why this won't print anything, because we are accessing vec0, but as it remains empty, we have not modified it, it prints actually nothing. And then this push, and then we have the values that will, these values that will be printed out over here. So there is actually a second option, and that's when we make first this mutable. So we make this mutable, so we can then pass it as a mutable reference. So we pass to fillvec a mutable reference, and this will get passed here. So we have also to change the function signature, and this will get a reference mutable reference. Then we will mutate this, and we will return vec of integer type. So what's left is that we actually have to clone that. We have to clone this vector that will get passed over here, because this is mutable, because the function signature actually expects a vector of type integer. So we have to return that. Because if we did not clone here, let me first compile that one to show it's working. And as you can see, everything is fine. And as you also can see, the first line will print actually these values over here, because we are in fact mutating this original vector. So if we did not clone that one here, we have here expected struct vec found mutable vector, or a mutable reference to a vector. So we have to clone this one. All right. Number 3, make me compile without adding new lines, just changing existing lines. Again, starting in main function, we create a new empty vector, store it in vec0, we pass ownership of vec0 to fill vector, and then this will get passed here. We modify the vector, return it, and this will then hold this vector, and like that, and then we will print vec1. We push again 44, 66, 88, like that, and we again print vector 1. So what's the problem? Cannot borrow as mutable. Cannot borrow as mutable. So what we here have the problem is we pass vec0 over here, but we didn't make that one mutable. So it has to be mutable. Let's see. And it's compiling, because as you can see, this is vec0, and we had to make this one just mutable. Maybe you remember in the first exercises, we had this. I think this would also have compiled. And as you can see, it's compiling. But this is actually very verbose. You don't need an extra line for that. So actually what we did here is just taking this vector and put it in a new variable which is mutable. So this can be done in one single line directly, and we pass here the vector and make it mutable. So let's see. Okay. Refactor this code so that instead of passing vector 0 or vec0 into the fillVec function, the function or the vector gets created in the function itself and passed back to the main function. So again, we start in the main function, and we basically won't need this line, because what we will do is, again, you see the same thing. We passed vec0 to fillVec, but in here we don't need that, because we just make the vector inside the function fillVec. So instead of passing it and making this of the argument, we can just call here vec new. So we create an empty vector and we push these values inside this vector, return it, and it will get passed into this one. So actually we will have over here 22, 44, 66, and then over here we will push 22, 44, 66, we will push 88. Now it should compile, and as you can see, it's compiling. So all we had to do is call this function without any argument, and then in here in the function itself we create the new vector. Make me compile only by reordering the lines in main, but without adding, changing, or removing any of them. So over here we got a variable x which is mutable of value 100. Then we create epsilon which will take a mutable reference of x, and then we have z, and we also take a mutable reference of x. Then we dereference epsilon and add to it 100. And here the same thing for z, we add to it 1000. So actually, as you can see, first mutable borrow occurs here, second mutable borrow occurs here. So that's a rule in the Rust borrow checker. So you can't have two mutable references in the same scope. So this scope is main, this is the main function, and in this scope you cannot have two mutable references. You can have immutable references as much as you like, but mutable references you can only have one in the same scope. And you also can't have a reference and a mutable reference in the same scope. But there is an exception, and I have seen that in the Rust book. You can go to the Rust homepage and you will see this book. And as you can see here is an example. We have here a mutable variable s, and we put a string inside this variable, and then we pass it references. And these are not mutable references, only s here is mutable. These are normal references, and this is no problem. And then we can also pass a mutable reference over here, and that's also no problem, because actually we have used these two references, because actually it's not possible to have immutable references and mutable references in the same scope. But when you use the variables, they can be used after that. So you can then have a mutable reference of it because they have been actually used. So all we have to do here, we can't add, change, or remove anything. We just have to reorder, and that's why we will put this line over here. So we get a mutable reference of x inside the epsilon variable, and then we add to it 100. And as you can see, we have actually used epsilon, and that's why we can then have a second mutable reference to x, because this is already used. So we have z, and we add 1000 to it. Let's save. And the code is compiling. And we are in the last exercise. So what we have over here, we start in the main function. We have here a string literal, and then we will create of it a string object. So this here, this variable data, is of type string. And maybe I should explain, there are two types of strings in Rust. We have one-time string, and this is a string literal. And it is fixed size and cannot be modified. And then we have a string object like that, and this is not fixed size, so it can be dynamically changed and it can be modified. And that's basically the difference. So here we have a string literal, and if we would make it like that, so the type would be here string. If we just had that, it's a string literal. But we have over here to string, so we make this string literal, to a string object. Then we will pass this variable data to the getChar function. So we land over here, and as you can see, we expect data which is of type string, and we just take chars and the last char, and we return it. So here it says should not take ownership. So we should actually pass here a reference and not ownership. We don't pass this variable. We just pass the reference to memory of this variable data. And here, of course, you have also to define it that you will only take a reference. Okay, and the second one should take ownership. So we pass here a reference and it makes it mutable and puts it to uppercase. Mutable here is necessary because to uppercase will actually modify the data, while here it's just reading the last char and returning it. It doesn't get modified. So here we should not take ownership, or we should take ownership. So here we don't pass reference, we pass ownership, we pass the actual data. And over here we remove that and we made this mutable and to uppercase. We will see if it's compiling, and of course we in here we have also a reference. I didn't see that. Like here we don't pass reference, we modify the data directly, and it is compiling. And as you can see in the output, we have capitalized every letter of the original string. This was the original string, and we have made every letter in here to uppercase. Okay. And that's it. The next topic will be structs. See you then.